Hello everyone, thanks for checking out my YouTube video. Today I'm going to be showing you how to swap your existing micro port with a USB Type-C port. This is going to be a long video. This one's going to go into detail of how I create the adapter basically. I may post a shorter version that just shows you how to put the adapter into the micro, but I think posting this would be interesting to a few people. This is a 12-pin USB Type-C connector I got off AliExpress, and a custom designed PCB I ordered from JLC PCB. I made this mod so that anyone with relatively decent soldering skills could do this mod relatively easy. The design should be well suited for the micro. I've done a port mod before with a lightning connector. Very similar design, but USB Type-C, in my opinion, is much more popular. So I decided to make this mod as well. Right now I am breaking off these plastic tabs on the underside of the port. I tried to put the holes in the PCB to allow for the port to sit on the PCB, but with all the lines that go through that small area, there wasn't any room to put the holes in, so I just broke off the tiny prongs. Not all 12 pins are utilized in this design, but soldering all of them is still pretty difficult. I don't really have an accurate measuring tool, so I use this PCB I designed as a standard in order to get my measurements, but the design for this PCB is very accurate to the design of the USB Type-C port. Obviously I had to use a lot of flux on these pins to make sure that the solder flowed well and stuck. Looking back at it now, I think I probably should have tinned the pins first. That might have made it easier. It took a few tries to get all the pins connected properly. Right now I'm just cleaning the pins off with some isopropyl alcohol. You'll see that I clean very often. I guess it's just OCD. I will make a note that this mod is only compatible with USB Type-A to USB Type-C cables. This will not work on a USB Type-C to USB Type-C cable. I'm working on a design for that right now. Right now, I really wish I had one of those helping hand utensils, because trying to solder and hold this thing in place is very difficult, and I burned my hands a few times. Right now I'm just putting flux on the pads so that the solder flows into the holes and anchors the USB to the PCB. The goal is to make sure I have a good amount of solder anchoring that USB Type-C port, but also need to make sure that I don't put so much solder that it bubbles up. I have to try to keep this as flat as possible, because this is going to be pressed up against the board of the micro. As you can see, my finger is holding the adapter into place, and right now is getting extremely burnt. So I definitely need to invest in one of those helping hands. If I do end up selling these, they're gonna come pre-made. It's already gonna be soldered onto the PCB, so most people don't have to worry about this, but I still think some people will be interested in the process. There we go. Alright, now I'm just trying to smooth it out. Make sure that it will be able to sit flush with the PCB of the Game Boy Micro. Now after this, I did make a few more adapters and found out that it's not the best idea to put flux on these tiny pads, because you'll see later on that my end goal is to have the to have the solder kind of point outward or upward, and with the flux there, it just balls up the solder. I want the solder to be pointed upward because it makes placing the adapter into the Game Boy Micro very easy, because the solder that points upward will be able to align with the holes on the Game Boy Micro. So right now the solder just balls up and it's not sticking upward. Later on in the video, I'll try to insert a picture to show you exactly what I mean. But for now, I'm just cleaning off the PCB. Unfortunately, I added more flux. Doesn't really help the case, but still ended up getting the job done. Always be sure to tin your soldering iron. Especially since this board is so small, you don't really have the ability to heat up the pad, put solder on the pad, and hold the PCB at the same time. So I just dab down and try to lift up quickly so that the solder rises and it dries into a spike. That's the goal here. Also, I found out after making a few more adapters is that it's easier to do this before actually anchoring the USB Type-C port onto the PCB. So once again, cleaning the PCB, removing any residue, and as you can see, you have these spikes sticking off the PCB, and those spikes will align with the holes on the Game Boy Micro PCB. Alright, so I decided I would show you guys how to remove the port from a Game Boy Micro. Without a hot air station, it's very difficult. I've done it before and it was not fun. Sometimes if you've never added new solder to a micro port, that old solder doesn't really like to melt. So sometimes adding new solder will help it melt. So if this was an old port, the first thing I'd do would be add fresh new solder onto those old solder joints. I've never recorded myself doing any kind of mod on the Game Boy, so obviously when I do record myself, things don't go as smoothly as they usually go. Looking back on it now, I should have used flux, or I like to use flux when wicking up solder. It just helps pick up that solder a lot easier. As you can see right here, I'm kind of struggling to get that solder to wick up. Also, when you want to wick up solder, it's good to tin your soldering iron, have a little bit of solder at the tip there, so that the heat dissipates over a larger surface area and it heats up that solder on the joint. It makes it easier for it to flow up the wick. So when I was doing all this wicking, it was not going very smooth. I assume it was because I didn't really have flux on those joints. When you are wicking, it's good to keep the iron on the joint as long as you can, and you can see the solder rise up on the wick, and just leave it on there until you see the solder stop rising, and then just move on to the next joint. Since everything's so small in the micro, I try to keep my mind on the fact that I could accidentally remove a small resistor or capacitor if my wick is touching anything. So try to keep in mind not to have your wick touching anything else. So obviously this was pretty rough. Not my best wick job, but I'm just showing you this just in case you don't have a hot air station. I'm just showing you how to get as much solder up as you can. And even then, if you get every speck of solder off of this port, you'll find that removing the port is still pretty difficult. And you definitely want to be careful removing the port, because if you remove any pads, it is not an easy fix. Now also, if you do have a hot air station, I would suggest removing as much solder as you can. I do have good results when doing so, so that's why I'm also removing the solder here. I'm getting it prepared for the hot air station. Alright, it's always good to put flux on before you're about to remove the port. I find that flux helps melt solder a bit faster, in my opinion. Sometimes with old solder joints, if you're trying to heat it and melt it, it'll take a long time, and you don't want all that heat on certain components for long periods of time. So the faster you can heat it up and melt that solder, the better. Also, I wanted to show you guys probably the best way to remove this port if you don't have helping hands to help you. I just put some tweezers in the port, and you don't want to put a lot of pressure on the port because you still run the risk of removing pads. So right here I'm barely putting any pressure down. Mostly it's just gravity, but as you're heating, every so often apply a little bit of pressure. If it doesn't budge, stop applying pressure. Keep on heating. As you can see right there, the port literally just fell off. And that's what you want. You don't want to pull down as hard as you can. You just want it to fall. So after you got the port out, you want to clean the pads, remove any solder that's on the pads, because you want a good clean surface to mount your adapter on. Obviously I had to go back and clean with alcohol because I'm just a clean freak, but you don't have to clean that many times. Alright, here I actually used flux before trying to wick, and you can see in a little bit just how much more useful it was while trying to wick. So you tin the iron, get a little bit of solder on the tip, and that'll help flow the solder up. You want to make sure all those holes are nice and cleared. Everything wicked up nicely. More flux. Right here, you got to be careful of surrounding components. You don't want to accidentally wick up something or, move something out of the way. Especially on the micro, everything's all close and compact together. Always be mindful of that. So everything's all wicked up. It looks very nice. Just run through it with some alcohol. Make sure your surface is clean and prepared for mounting the adapter. Now, if you are a beginner, I would highly suggest getting a hot air station, um, because trying to remove this with just a solder wick is a huge pain in the butt. I do understand that a lot of people don't have hot air stations. I didn't have one until I tried doing the lightning port mod, and I had to remove it, and there was no way for me to remove it. So I bit the bullet, got a hot air station, and it is amazing. So much easier. So here we're ready to put the adapter on. This is how the adapter will probably come if I end up selling it. You will be responsible for removing your port, but the adapter, when you get it, should just slide easily into those holes. At first I was worried because I was like, how, which side do I mount this on? I don't remember, but the way the holes are on the PCB, they only go one way, so you should be fine. So those solder spikes I was talking about before, they will sit inside those holes, and they will act as a guide to place the PCB correctly into the micro. So right now I'm putting flux on the pads here. It's good to pre-tin your soldering iron because your hand is going to be full holding the port into place, and having that solder on the tip of your iron and the flux on those pads, all you have to do is just tap the soldering iron on the hole and it will act as an anchor and hold the port in place. Alright, so right now I'm checking to make sure that the adapter is as flush as it can be to the PCB. Unfortunately, the adapter PCB, the custom one I made, is a bit too thick. It's 1 millimeter thick. I think I need to go to 0.8 millimeters. So you want to make sure that the PCB is flush with the micro. Now we're putting flux on the anchor points. You want to make sure you put enough solder into those holes, because you need to make a connection through those holes and onto the pad beneath. If you don't put enough solder in, the solder will only coat the top of the hole. It won't go through and it won't make contact with the pad below. So make sure you put enough solder in. For this demonstration, I'm just showing you how to put the port on, so I don't put a lot of solder into the holes. Now when you're doing these small pinholes, you do want to make sure you hit a sweet spot. You want to put enough solder in there so that the holes and the pad below make contact, but you don't want to put too much in. I haven't had this happen to me, but I do worry that if I put too much in, the pads below will short with each other. So try to find a sweet spot. I've never had it happen. I don't know if it could happen, but I feel like if I put too much, they'll all just blob together. So definitely be mindful of that. And if it does blob together, if you have a hot air station, removing the port Should not be a problem. Should be relatively easy. Much easier than removing the original port. If you don't have a hot air station, I'm not sure what to tell you. I tried to wick it one time on the lightning port, and that's the main reason why I went out and bought a hot air station, because I just could not get the adapter off. It was not coming off. So if you don't have a hot air station, be very careful on this step. Now, if you want to check if this works at this point, if you plug in a USB Type-C cable, the pad on the far left should be your negative, and the pad on the far right should be your positive. Pad on the left top is negative, pad on the right bottom is positive. You can check to see if you get 5 volts through those. If you are checking through shorts, if you're checking for shorts on these pads, just know that the ground and negative pad are, how do you say? They're shorted. So you'll get continuity between the top left pad and the bottom left pad. And that's it. That'll be your port mod. Thank you guys for watching. I hope you enjoyed the video. I hope it was informational. If I do sell these, I hope you guys buy them, and I hope they teach you a little bit about soldering. Thank you guys again for watching. Have a great day.